This problem is from IEEE 2008. It's given that there is a capacitor which capacitance is 9 picofarad. The distance between the plates is d. Now it says that in this capacitor two dielectrics are filled in this space. Here it was air between the plates. Here it says the space is filled with two dielectrics of different dielectric strength. So say this dielectric strength is K1 and its dielectric strength is K2. Their values are given. This is 6 and this is given as 3, and they have given this thickness. This is d by 3 and this thickness is given as twice d divided by 3. Now the question is asking us what is the new capacitance of this. So this is a type of problem that comes quite often. So let me explain it in detail. So first thing, when we get a question like this, we should understand that once the space is filled up with dielectric, then this will act as a capacitor, this part. So let's call its capacitance to be C1, and this part will act as a second capacitor. Let's call its capacitance C2. So that means instead of one capacitor, now we have two capacitors. This capacitance is C1, this distance is d by 3, and this capacitor is of capacitance C2, and this thickness of the dielectric is twice d by 3. Now to find the equivalent capacitance, that is the total capacitance of this, we proceed like this. So here, since the space between the plates is filled with dielectrics, it should come to our mind that we should use this formula: capacitance is equal to epsilon naught A divided by D. So this is capacitance of this capacitor. Since this is air capacitor, so this is epsilon naught. So area of the plate is A divided by distance between the plates divided by D. So this is 9 picofarad as per the question. Now here the capacitor, the first capacitor, which capacitance is C1, that C1 will become similar to this equation, but this formula. Instead of epsilon naught, it will become K1 into epsilon naught, because the space in between, space here is filled with dielectric K1. So it will be K1 epsilon naught multiplied by the area of the plate. So a little common sense will tell us that if the area of the plate here is A, area of the plate here will also be A, because the dielectric is filled like this. So area of the plate is A. What I mean by saying the dielectric is filled like this is, in some other questions we may get a question like this: this was the original air capacitor, that is inside between the plates there is air. Now dielectric is filled like this. So say this is K1 dielectric and this is K2 dielectric. In that case, if the original plate was A, here for this capacitor the area will not be A, it will be something different. For this capacitor also, area of the plate will be not A, it will be something different. If in the question it's given that this is filled half filled with K1 and half filled with K2, then area will be equal to A by 2. Here also area will be equal to A by 2. But that is a different problem. Just to make you clear about this situation and that situation. So why here the area is A, I referred to this problem. Okay, now let's come back to our question. If you see here, for the first capacitor, its capacitance C1 is K1 into epsilon naught into area A divided by the distance between the plates. The distance between the plates is D by 3. See here, what we do is, when we say there are two capacitors, for the first capacitor this is one plate and this join is the second plate. This we should understand. For the second capacitor, this is one plate and this joint is the second plate. Okay, so C1 is this much, C2 will be similarly. See, first is, here it was K1 into epsilon naught, so here it will be K2 into epsilon naught multiplied by area of this capacitor, so that is the plate of this capacitor, that is A, divided by the distance between the plates of this capacitor. So distance between these plates is twice D divided by 3. So this is C2. Now we have to think one more step, that is how these C1 and C2 are connected. Are they in series or are they in parallel? That we have to decide. Now think like this. This capacitor C1 connection is here on this plate. The second plate of C1 is connected to the first plate of C2, and the second plate of C2 is connected like this. So this is similar to this. Say if this is C1, this is here, this plate is this plate. Now this plate is connected to the first plate of C2 and the second plate of C2 is connected, which is this. So from here we conclude that they are connected in series. So C1 and C2 are connected in series. Okay, so therefore what we have is its equivalent capacitance. If I call that equivalent capacitance as CP or C, say if I call it CS because they are in series connection, so that S, so I know the equation is 1 by CS is 1 by C1 plus 1 by C2. We have to find CS. Now we can simplify it here before calculating. See here, this 3 will go up, K1 is there, epsilon naught A divided by D, and from here epsilon naught A divided by D is 9 picofarad. So I can write here 3, or if I write here, this will be equal to 3. K1 is given as 3 and this much is 9, so that is 81 picofarad. So that is C1. Similarly, if I do this, C2, that will be K2 is given as 6. This 3 will go to the top, 2 will remain in the denominator. Epsilon naught A by D, that is given as 9 picofarad. So this will be again 81 picofarad. That means C1 is also 81 picofarad, C2 is also 81 picofarad. So if we want, we can use this, or we can straight away say two capacitors 81 picofarad and 81 picofarad are in series, so the equivalent is half of that, so 40.5. Or if we use this formula, 1 by CS will be 1 by 81 plus 1 by 81 picofarad, that is 2 by 81. Therefore CS will be equal to 40.5 picofarad, and that is option C. So correct option for this problem is option C. While explaining this problem, I have explained something about this combination also. In this problem, the dielectric were filled like this. In another problem, the dielectric may be filled like this. One dielectric in the upper portion, half of the capacitor, and here second dielectric in the lower half. In that case, these two capacitors, if I call it C1 and if I call it C2, they will be, the C1 and C2 will be in parallel. They will be in parallel. Why parallel? Because for C1, this is one plate, this is second plate. For C2, this is one plate, this is second plate. So this plate and this plate are connected, and this plate and this plate are connected. So this is a parallel combination of C1 and C2. So two types of problems usually come. If it is filled like this, this is a series connection. If it is filled like this, this is a parallel combination.